right, so okay, I hope it's recording now, and we're gonna start with the first question.
Okay, should I
So,
mute my thing?
hello, yeah. Are you saying something? I'm sorry, I can't hear you.
Oh no, I was asking if I should mute my thing.
No, keep it on mute. Like, I actually want it on mute right now. So,
Okay.
okay, so this is the first question. So we have two cars that are going in the same direction, and both of them start at the same time, as it is evident from their starting points of their speed time graphs. Okay, so a few things about speed time graphs. First, that the area under a speed time graph represents what?
Distance.
Distance traveled in the time. Distance traveled. Okay, so the question that you sent me said that we have to find the time t at which the car A overtakes car B. Was it car A overtakes B? Wait. The time, yeah, A overtakes B. Is that the only question that you want me to tell you?
Yeah. Yeah,
Okay.
on this question.
Okay. So here's the thing. We see that the car B is traveling with, let's zoom into the graph a bit. So we can say that car B is traveling with constant speed. Is that right?
Yeah.
So there's a small portion of time uh, that for which car A travels at a constant acceleration, but then after this time, car A is also traveling at a constant speed. Is that correct?
Yeah.
Okay, wonderful. So the thing is that we have to find the time t at which car A overtakes car B. In simpler words, we have to find the time at which car A, the distance traveled by A equals distance traveled by B. Are you following this?
Why when it's equal and not when it's small?
Oh, okay. So let's draw a row so that this looks like more realistic. So this is one lane, and this is so okay. So let's say this is at the time where this is. I'm sorry. I'll just write B, and this is A. Since the speed of A is increasing, there has to be a time where B is moving at a speed is a constant speed of 40 meter per second, and A is accelerating, and it's going in. Since it's going in the same direction, we can say that it's going towards B. Is that correct?
Yeah.
So there's going to be a time where B and A will actually be parallel to each other. They will be like side by side to each other. Is that correct? And they will still be moving, and B will be moving with a constant speed, and A might be accelerating.
Is that because B starts? I mean, is that because A starts at a slower velocity?
So,
Or?
It's because the speeds of B and A are different. So although A starts at a lower speed than B does, but it eventually it starts moving at a much greater speed than B is moving. So it's quite normal that like when you're on a road and you overtake a car, that means that your car is moving faster than the car that you're overtaking. Okay,
Okay. Yeah.
is that like, are you following this?
Yeah.
But you're not, obviously your question is valid here. Then now, since we're mostly talking about speed, how are we calculating distance? How are we making the equations of distance? Is that are you following this? Are you following what I'm thinking?
Yeah. Yeah.
Okay. Since we're talking about speeds mostly, then why is it that we're making an equation using the distance traveled by A and distance traveled by B? So what I'm saying here in the equation, that we have to find an instance or a value of time t at which the distance traveled by A is equal to the distance traveled by B. Because I'm talking about this particular point, when when B is actually when B is actually obviously moving at a constant speed, but A is accelerating, and after this point, A will overtake. So this is going to be B, and this is somewhat A is. Okay, are you following this?
Yeah. Yeah.
So at this point, the distances traveled by B and A are actually equal. This is the time t that we're looking for, because after this time t, the car A actually overtakes car B, and it can be anywhere on this graph. It can be this one, it can be this one, it can be this one, or it can be this one. Anything. But we're not concerned about this right now. We're concerned about you actually being able to follow why we're actually using the distances traveled by A and distance traveled by B. Why are we so concerned about that? Are you able to understand what I'm saying? You can say no if
Yeah.
you want.
Yeah. No, I understand.
Okay. Okay, so now now let's move on to a question, like how are we going to suppose, like, finding the distance traveled by B is easy. Like, you can just multiply this. So B is moving at a constant speed of 14 meter per second. You can multiply 14 by t, and you will be able to get the answer. Okay.
Is the time at which the lines cross over?
Oh, okay. So that, no, this point only represents the time when the speeds of A and B are same. They don't say anything about the distance. So distance, the way we relate distance to a speed time graph is through area and not the y value or the x value. So this particular point only tells me that the uh, the speed at this point t, at this time t, the speeds of A and B are equal. This doesn't say anything about distance. We can find the area and their distances will be different.
Is it when the area under the graph is equal?
Yeah, it is when the area under the graph is equal. So this has to be the area under the graph obviously is equal. So we have to find a particular time t at which the area under the graph is equal, and not where the lines intersect the graph actually meet each other.
Uh,
Okay, are you following this?
yeah.
Okay, so all right, let me take a guess. If the So if the time t that I'm looking for actually happens in between this part of the course where A is actually accelerating, then we might be facing a then the area under the graph is different. But if A overtakes actually when the car A accelerates B when it is in this part of the course, so in the constant speed. So this is constant speed, and this is constant acceleration. Are you following this?
Yeah.
Okay. So when the car A has constant acceleration, the distance that it covers actually is, how much is the distance from 4 to I think uh, you used you found this in a part previous to this one. Let me see. uh, okay, yeah, you have found that the car A travels 44 meters in the first 4 seconds in B part two of this question. Is that correct?
Yeah, I think
Yeah, you have written the answers. I'm supposing you solved it, although you haven't like um, shown any formula. Okay, you've written on the graph. Okay. Um, this is 10. This is 24. 44 times 2. 24 times 4 is 44 times 4. Okay. Yeah, I think I might. Oh no, no, no. 34 times 4 is 100. 20. Where is my calculator? I just need to verify this answer. Or have you verified the answer?
I'm checking now.
Mm-hmm. So 10 plus 20. It's 4.
Yeah, I got the same answer.
No, actually, I think your answer might be incorrect. The correct answer actually is 68 meters.
The graph starts from 6 on the
Yeah, but it
um,
has to like it. We can't like say that there isn't the graph is there. It's just not drawn. So the graph actually is the does come here to 0. So what formula did you use to find this? Did you use the formula for trapezium, or did you just split this trapezium into a triangle and into a
I did a triangle and a rectangle.
okay, and I see why you did it incorrect. Okay, so we'll get back to this. Obviously, we're concentrating here right now. So the correct answer is 68 for the area that is traveled, the car travels for in the first 4 seconds. Okay.
Okay.
So okay, so the approach here is that to see how much time, how much distance the car B travels in the first 4 seconds. And the answer is in 68 meters. In the first 4 seconds, the A travels, and B travels 14 times 4, which is um, how much is 14 times 4? For 56 meters only. So at some point in between 0 and 4, car A actually overtakes car B. Okay, so
Yeah.
let's say this is time t, and okay, this is time t. So how will we find this area? We're gonna use the trapezium formula. We can draw a graph here where this is 10, this goes to t, this is t, this is t. Oh, okay. I think this got trickier. We don't know the speed as well. So this is time t, and this is the speed at which the car actually overtakes. Okay. Mm, what am I drawing wrong here? Let me see. 10. Okay, 10 plus 24. Multiplied by 4 divided by 2, 68, and 14 times 4 is 56. Actually less. So 8 divided by 14, 4.9. Hmm. 1.2, the time at which have the same velocity. Okay, just give me a second. Just give me a second. I'm figuring something out. The actually the distance traveled by this, so this is 44. Okay, 28 and times the height. Mm. Mm-hmm. Yeah, this should be the right thing. But what about the speed? What about the speed? Or side by side? Okay. Drawings at a constant volume first. Okay. Hmm. Hmm. Okay. So the thing is that the car, we don't know the speed at which the car overtakes this. So for which the area it's necessary actually in the first 4 seconds it travels. Can you do you have the answers to these questions?
Yeah, I can look for them.
Okay, can you please check that the answer for the part two is 68 or not? Because
Okay.
if it's not 68, then I might be incorrect. For part two of this thing, I think I'm doing something wrong. I don't know what.
Okay.
Uh, uh, Calculate the distance traveled by 4 seconds. It's a trapezium, so 24 plus 10. Consider trapezium. So car uh, 10 plus 6 times 4. Wow. 10 plus 24. 24 times 4.
And yeah, you were right. The distance is 68.
The distance is 68.
No, 68.
60.
60. 68.
68. So 68.
Yeah.
Okay, so it's the answer is 68, obviously. So I'm right about that, but the thing is that for the first 4 seconds, the car B travels only 56 meters. So okay, here's the thing. 56 meters. Okay, so we have to find the time t where the distance traveled by A is equal to the distance traveled by B. So we cannot actually use this graph to find the distance traveled by A. We have to use a formula that we will be using to find the distance that the car travels at. So, okay, so distance traveled by B is 14 times T. Okay, and distance traveled by A is actually equals to UT plus half AT squared. Now we know the value of U. We know that the value of U is actually 12 meter per second, is if that's the initial speed. It's 10 actually. So it's 10, and the acceleration is actually 5 meter per second square. Okay,
Okay.
are you following this?
Um, um, yeah.
You can say no, like I'll just explain the whole thing again. Because if you aren't okay right now, then you might have a problem. What's this? Okay. Are you sure that you're fine
Uh,
with this?
um, how do you know the values that you've put in?
So okay.
So
So
like for T, you use 10.
okay. So the here no values are there. So, okay. So for the car B, the time t can be actually anywhere on this graph. So even if it's here, you just multiply it by 14 to find the area under the graph, or just use, because this is time. As I mentioned in the start, that car B is actually traveling at a constant speed. Okay. car
Yeah.
b car b is traveling at a constant speed. So if you ask me at time t is equals to 2, how much did car b travel, well, I'll just multiply it by 14, and I'll say 14 times 2, that's 28 meters. Okay,
Yeah.
so this is actually the speed, the constant speed that the b is moving at. And distance traveled by A is simply S is equals to UT plus half AT squared. Now I know I haven't taught you this formula, but it's something you already know. Is that correct?
Yeah. See that equation.
So u is actually the initial velocity and a is the acceleration. Okay. Hello, Sarah, are you with me?
Yeah, no, yeah. Yeah.
Okay, just keep your mic on mute. So the initial velocity of the car A was 10, and the acceleration was 5. Okay, you calculated it yourself. It's actually, okay, no. The acceleration is, we can like find the acceleration as well. Okay, you know how to find the acceleration?
Change in velocity over time.
So the velocity changes from 10 to 24 in 4 seconds. So I'll just write 10 to 24, the change is 14 meters per second, 14 meters per second, and it came over in a time of 4 seconds. So 14 divided by 4, which is 3.5. Sorry. Okay.
Yeah, okay.
So what we're gonna do is we're gonna equate these two equations. We're gonna say 14t is equals to 10t plus, I'll just write 7 by 4 t squared, and we'll write 7 by 4 t squared minus 4t is equals to 0. And the answer is t is equals to 0, and 7 by 4t minus 4 is equals to 0. So t is equals to 16 divided by 7, or what's 16 divided by 7? 2.29 seconds. Okay.
Yeah, but how did you get 3.5 for the acceleration?
3.5 acceleration, how did I get? So I just told you that you just told me that acceleration is change in velocity over time. So the velocity changed from 10 to 24 in 4 seconds. Do you agree with this?
Yeah.
So the change actually was 24 minus 10. So A is equals to V minus U divided by T. A is V was 24, U was 10, and the time it took was 4 seconds, and A was equals to 3.5 meter per second square. Is that okay with you?
Yeah.
So is the answer correct? I just want to double check.
Yeah, I checked.
Okay. So is the working clear? We're going to move on to the next question.
How did you get the time for the t squared?
Which one are you talking about? The how do I solve this equation?
Yeah.
So I took t common, and then 7 by 4 t minus 4 is equals to 0. So from this, we have two solutions for t, which is t is equals to 0, or 7 by 4 t minus 4 is equals to 0. And t was, I actually made t the subject from here. So t was 4 times 4 divided by 7. Is it clear? Like, is the math clear? Because the math isn't difficult. It's just a quadratic equation.
Yeah, it's fine. Yeah.
Mhm. Okay, so the next question is of what do I call this? Um, forgetting the name of this term. Okay. So okay, describe the energy conversion. Okay, so the next question that you sent me was from the, why am I forgetting this? So it's of a projectile motion question.
Yeah.
So yeah, so it's a half projectile. It's a very easy thing to, so the first thing that we need to do is to describe the energy conversion that takes place from a hose to pipe to the ground. So when it leaves the hose, the water has kinetic energy. When it's going down, it loses gravitational potential energy. And then you may assume that so there isn't any loss because of air resistance or anything. So the water hits the ground, and all of the energy of the ground of the water is actually absorbed by the ground. Okay, in some form of energy. It can be sound, it can be heat energy, it can be anything. So we just write that when the water leaves the pipe, the water has kinetic energy, but as soon as it's moving down, coming down to the ground, it's losing that kinetic energy in the form of gravitational potential energy. It's losing that energy, and as soon as it hits the ground, all of the energy the water has is absorbed by ground, and some of the energy gets wasted in form of sound energy or anything, but the rest of it is all absorbed by the ground. Is it clear?
Yeah.
Okay, so let's move on to the next question, which was to explain why the horizontal component of the velocity remains constant at 7 meters per second. The answer to which is there is no air resistance, so there isn't any resultant force. So that the water takes about, okay, show that the water takes about 0.5 seconds to travel from there to there. Let me see if you did this correctly, because you've sent me the solution. I just want to check if you've done this correctly. 3.6 x as so. Where the hell did it go? Okay, here it is. So it travels 1.3 meters in the vertical thing where it does. Okay, you've done this incorrect. I think yes, you've done it again. So they're asking you to prove that the water actually takes approximately 0.5 seconds to reach the ground. Okay.
Yeah.
And so they've actually, technically, according to me, they've given you a hint when they told you that the water has constant velocity in the horizontal direction. So in the horizontal direction, we know that horizontally, the distance traveled is 7 meters. Sorry, it's so sorry, is 3.6 meters. So this distance, I'm talking about this distance. Okay, and the constant velocity is 7 meter per second. What's time? Now the time is actually distance divided by the constant velocity. Okay, so distance is 3.6 meters and the velocity is 7 meters per second. This comes out to be approximately 0.5 seconds. Are you following this? Your mic is on mute. I would like if your mic remains on mute. Like you shouldn't like mute your mic.
Wait, should I keep it muted or not?
Just keep it unmute. Don't mute your mic. Just keep it unmute at all times. So your mic should be open at all times.
Oh, okay.
Sorry, I'm sorry I didn't make that clear. So the distance t, the distance that the water travels horizontally was actually given, which is 3.6 meters. And the question told you already that the water has a constant velocity in the horizontal direction, that is 7 meters per second. And just use these two information to find the time, which is t is equals to distance over distance upon speed, which is 3.6 divided by 7, which is approximately 0.5 seconds.
Okay.
So that this makes it easier.
Do you only do it like this if the velocity is constant?
I'm sorry, I didn't follow this. What were you asking?
Like, you didn't use any of the Suva equations. You just used distance equals.
Yeah. Yes.
Yeah.
Yes.
Is it because the velocity is constant?
Yes, it's because the velocity is constant, and yes, that's why I used it.
Okay. Okay.
So now moving on to the next part, that is the proof that the show that the speed of water when it hits the ground is 8.6 meters per second. Okay, so to find the speed of water, we need to find the magnitude of the velocity when the water is reaching the ground. Okay.
Okay.
So we know that the horizontal component is equals to 7 meters per second. Now what's the vertical component? Vx, this is Vx, the vertical is Vy, which we don't know. So we'll just use an equation which perfectly suits our working, which is V is equals to U plus AT, and we'll apply it to all the vertical components of the velocity of water when as it moves down from the hose to the ground. So V is actually Vy, which we're looking for. U is 0 because velocity there isn't any change there. When the water leaves the hose, it's actually horizontal, and the vertical component of the velocity is 0. So this is 0. The acceleration is 9.81 times time, which is 0.5 meters per second.
Yeah.
So The vertical velocity is actually 9.81 times 0.5, which is 4.91. So this is squared. So what we're gonna do is we know that now that we know that Vy is actually 4.91 meter per second. We'll find the velocity, the components by just taking the square root of their squares. So V comes out to be 8.6 meter per second. That's what they were asking.
Why are you square rooting the answer?
Oh, so this is actually the magnitude, the way we find the magnitude. So when a vector has vertical and horizontal components, we find the magnitude by using this formula. So do you know this formula, or should I teach you this? Because I can teach you, like I can give you an overview of this formula.
Which formula? V equals U plus AT.
No, the square one, this one. Were you asking about this formula or something else?
Yeah, that one. Is that the V squared equals U squared plus 2AS?
Oh, no. This is the formula for the magnitude of a vector which has horizontal and vertical components. So if this is a force, if this is the velocity, was actually equals to Vx and Vy, which we found individually was 7 and 4.9. So I said the magnitude of V is actually equals to 7 squared plus 4.9 squared. This represents the speed.
Okay.
Are you familiar with vectors? Because this is like a concept that is taught in the chapter of vectors.
I've never seen this formula before.
You have never seen this formula before. Okay, so we need to study this chapter of vectors. So this is like a very difficult thing. This is taught in math as well. So if you're taking math, then you're gonna see this formula. Okay.
Wait, so what is the formula? Is
Can you see the board?
yeah. So I just write that down. Yeah.
So
So you divide the initial velocity in the x direction,
and the
you
velocity in the y direction. So I had like the individual components of the velocity, but I didn't have the exact velocity, which was actually the speed.
okay.
So are you able to follow this?
Yeah, it makes sense because this just takes away the direction, right? Okay. Yeah, it's all right.
Oh, okay. So like we can move forward now.
Yeah.
Okay. So the next question that you sent to me was all right, let me read this question. So it's two masses A and B. The string masses this, and wheel mass. Hmm. 2.8. Mm-hmm. Mm-hmm. Oh, but this seems like an easy question. Like, I don't know why you asked this. All right then. Okay, so they're saying that mass B hits the floor with 2.47. So initial velocity U was 2.47. It rebounds with a speed of 1.50 meter per second. So the velocity V was actually 1.50 meter per second, the final velocity. And they're saying that the time they took was 3 into exponent negative 2 seconds. Acceleration is simply v minus u divided by time. Are you familiar with this?
Yeah, like with what?
So this is the question of the sorry, I'm not sure if so it's this question.
Yeah.
So from this question, that there are two masses and the B is released. So you've done all of the rest of the parts you've done. I hope you've done it correctly. And the part that you circled is the part 4, which is mass B hits the floor at the speed of 2.47 meter per second. It rebounds with a speed of 1.5 meter per second. So the initial velocity of the speed of the B was 2.47 and the final velocity was 1.5. And you have to find the magnitude of the acceleration. So,
Okay, yeah.
so acceleration is simply acceleration A is equals to V minus U divided by time, which is 1.5 minus 0 minus 2.47 divided by 3 exponent negative 2.
Oh, yeah.
Okay.
Yeah.
So the answer is negative 32.33 meter per second squared, and the magnitude magnitude is simply 32.33 meter per second squared. This is your answer.
Okay.
Can you just double check if I'm correct or not? I might be incorrect.
Okay. The acceleration is 132 meters per second squared.
132? Oh, okay.
132.
Oh, I must have missed something. Let me see. Let me just take it again. So this is 1.5 minus 2.47 divided by 3x minus -2, which is
For change in velocity, they added the 1.5 and the 2.47 instead of minusing it.
yeah. I see what I did incorrect actually. The thing is that it changes direction, so one of them has to be in negative. So it was coming down at B. I'm so sorry I missed this part. So when it touched the ground, the velocity was actually negative 2.47, and it
Yeah.
went up by 1.5. So it has to be 1.5 minus 2.47. So then the minus is plus. So the answer is 132.33. Yes. I made a mistake here. So, but you get the idea that it's simply um, the formula for acceleration.
Yeah, but it says it rebounds at the speed of
Yeah, so it rebounds means that it is coming down with the speed of 2.47. So the velocity actually is negative 2.47. It's not plus 2.47, it's negative because it's coming down.
But how do you know down is the negative direction and not up?
Up is the positive.
But why?
Yeah, but like this can be reversed as well. We can consider that down is positive and up is negative, but we will still end up with the same answer. The signs might be different, but the magnitudes will still be the same. Actually, as an exercise, if you want to do, consider down to be positive and up to be negative, and see that you'll have the answer of here I got the answer of positive 132.33. You'll just get negative 132.33 because you just reversed the directions of everything here, but the magnitude will still be the same.
So are both answers still right?
Yeah, that answer is still correct, but when you're writing magnitude, you ignore the sign. So you consider that
Okay.
the magnitude is always positive. There isn't any negative magnitude. Magnitude means that it's just simply the value, the actual magnitude is just always positive.
Yeah.
Okay.
Yeah.
Hmm. Calculate the time for the to reach the surface of the oil. Okay. So uh, so this is our question that the ball is 0.7 meters above the surface of the oil. So the distance is 0.7. Calculate the time taken to reach the surface of the ball. So it was when it's at the surface, when it actually starts its course, the value of initial velocity is 0 because it's held by something, it isn't moving. So this is initial velocity is 0, and since it's in the on Earth, we will just consider that it's accelerating with the acceleration of 9.81 meter per second squared. Now we have to find the time taken for the ball to travel 0.7 meters. So we'll just use this formula, ut plus half ad squared. S is 0.7, U is 0, T is something we need to find. So we write T 9.81, T squared. Okay, So this is
Yep.
0. This is 0. We'll just write half 9.81 into t squared is equals to 0.7. So t squared is equals to t squared is actually 0.1427 and t is 0.38.
Oh yeah. Yeah. Okay.
Do you get this question? It's simple. It's simply you will just use this one formula.
Yeah.
The velocity v against as it travels through the oil. Okay. Okay, so it's a completely different question. So now moving on to the next question you sent me. So I think you won't be getting this question as well, but let's me try doing this in front of you. Okay, so it's this question where you have to find the resultant force A and B of A and B actually, okay?
Okay.
So to find the resultant, first can I write force A in terms of its vertical and horizontal components? Now we can write it. The easier way to do this question is to write A and B as column vectors. Can you write A and B as column vectors?
I don't know how to do that.
Okay, so it's just simply a matrix where you write x x component of a force here and y component here. So I think you must have read. I'm sure you would have learned this in O levels or something. So Khair, did you do this in your GCSEs when you were doing?
Yeah, I think I did, but I don't really remember it that much.
Okay, all right. Let's do this right now. So A is in horizontally it is this much.
Yeah.
So we'll just write 2, and vertically it's this much. So we'll write 3. Let me do B with another pen. So horizontally B is this much. So we'll write 6, and vertically it's this much. We'll just write 2. Okay.
Yeah.
Are you good with this working?
Yeah.
Okay, so let's now find the resultant force A plus B. We'll just simply add these vectors, column vectors, to 3 plus 6, 2. This comes out to be 8, 5. So this is A plus B. But what they're asking us to do is they're asking us to find the magnitude of the resultant two forces. So the magnitude of A plus B is actually magnitude, just write mag under root 8 squared plus 5 squared, which is equals to under root 40 plus 25, which is equals to under root 65, which is equals to 8.06. Okay.
Yeah. Wait, why? Where does the 40 and the 25 come from?
Oh, so it's actually the square of. Okay, I'm just feeling like you need to revise this concept with me or like yourself, because this is like simply the column vectors. This is the x component, and the y component.
But I was asking this because 8 squared is 64. So why is
Oh, it's
40?
8 square 64. Sorry. Okay. 8 square 64. I did made a mistake again. So sorry. 4 plus 25 sorry, so sorry. This comes out to be under root of 89, which is equals to 9.43. Okay,
Yeah.
you get it now? I'm sorry, I just made a mathematical error.
Yeah, I get it.
Okay,
Wait, so is the magnitude just is it y component squared plus x component squared or square rooted?
yeah.
Okay.
Mm,
Does it work for any component of anything? So
yeah,
initial plus anything. Okay.
anything. Yeah, that's how the vectors are supposed to work. So magnitude of any vector is equals to the square root of the sum of the squares of its components.
Okay.
Okay, describe how the vertical component velocity of the water rises from x to z. Okay, so let me like so. Okay, let me do this question with you, and perhaps this is the last question I need to do with you.
Okay.
So, in the first thing they're asking is to describe the horizontal component from x to z of this water in the water that comes out from the water jet. So about the horizontal component, you're right that the horizontal component actually remains. Sorry, I'm not going to number this. Let's number it like this. It remains constant from x to z. Why does it remain constant? It's because there is no air resistance.
Okay.
Okay,
Yeah.
and so if it remains constant, that means that there is zero acceleration. Okay. Now
Yeah.
why did I write? So now in the second part, they're asking you to describe the vertical component of the water that comes out from the water jet. So the first thing is that it varies from x to z, but and at what you write is that it decreases to 0, and it is 0 at y. It is 0 at y. After this, it starts to increase till z. Okay,
Yeah.
and you're gonna write that the acceleration is equals to negative 9.81 always.
Okay.
Okay,
Yeah.
so it first decelerates and then till y, and after that it's actually plus 9.81 till z.
Yeah.
Okay, so this is the
Yeah.
description only of what I can think of. The drag force is we show that Okay, so about the units question,
Mhm.
how do you solve this question? So F is equals to K times A times V squared. Now, we have to find the units of K. I'm going to write this K in a separate color. So this is the variables for which we don't know the units for. So how can we find this? We're just going to write all the units of the variables we know. So the units, the stable SI units for the force is kg per meter per second squared. It's something that we assume that the candidate knows.
Mhm. Yeah.
So are you familiar with this?
Yeah.
So and the stable SI units for A are meter squared, and the stable SI units for V are meter per second actually, and squared this will be
Yeah.
okay. So we just write
Yeah.
everything all together. Kg meter per second squared divided by m squared multiplied by m squared s minus 2.
Mhm.
These are the units of K. So the units of K are actually equals to the units of K equal to, so we will just cancel out S and M. There's one M here and four M here, so it turns out to be Kg M minus. Okay, did
Yeah.
you get this? Okay, so these are all the questions that you sent to me on WhatsApp,
Mhm.
and I hope now everything is clear about these questions.
Yeah.
Okay, so from today's class, we learned that I actually got to know that you have to work on the vectors question, and
Mhm.
I really want to work on this question on that chapter. So if we can like set aside only like half an hour even in the next class, then we'll just go over the topics, just over that topic.
Okay.
Okay,
Yeah.
so that fine with you?
Yeah.
All right, so I'm gonna end this class and I'm gonna see you next week, inshallah.
Okay. Yeah.
All right. So nice meeting you today. I hope you understood and enjoyed the class.